We are live. Nice. So we have a problem, LeetCode problem here. And it's one of the first 1,000. So it's kind of the classics. It's called gas station. I've never seen it. Let's see what we can do. Let's first try to understand it. So there are n gas stations along a circular route. Circular, where the amount of gas at ith station is gas I. Okay. Okay, we have a circular route. You have a car with an unlimited gas tank. Okay. And it costs I of gas to travel from station. So there is also cost. Okay, from ith station to its next. Okay, unlimited gas tank. Wow, sounds magical. Sounds like a superpower. And it costs. Okay, we have a cost, and that shows how much of gas, how much gas you need to travel from ith station to its next I plus 1th. Given two integers, array, gas, and cost. Return the starting gas station's index. Starting gas station's index. If you can travel around the circuit once in the clockwise direction. Otherwise, return -1. If there exists, return -1. If there exists a solution, it is guaranteed to be unique. Okay. Let me try to understand what that means. So, given two integers. Integer arrays. Okay. Return the string. Jeez, what am I reading? Looks like my mind is just auto completing things. And return the starting gas station's index. Okay, one of the gas stations. If you can travel around the circuit once in the clockwise direction. And I'm thinking, like once means just once or at least once. Otherwise, return. Okay, there is one gas station. If you start there. Okay, let's see the examples. Okay, 1, 2, 3, 4, 5, and there is this cost. Output 3. Explanation. Start a gas station at station 3. Index 3, so that's this station. Fill up with 4. Unit of gas. Your tank is 4. Travel to station 4, so it's 4 minus. Cost is 1, so -1. At the next station, you get 5 units of gas. Then travels to station 0. Your tank is, so 4 minus 1 plus 5, you get 8. Then 8 minus 2 plus 1, you get 7. And then, okay, you get 6, you get 5. Travel to station 3, the cost is 5. 3, the cost is 5. I guess it's just enough to travel back to station 3. Okay, at 2 you will have 5. Therefore, return 3 at the starting index. So it looks like that the question is you can. I mean, it looks like you would be able to continue because at travel. Well, wait a second. You start at 3 and you end at 3. Yeah, but at 3 you would so at 3 you will have 4 units again, so you can start over. So that means, oh, well, yeah, by definition, if you can make a full circle and have positive gas tank, that means you can do it again. Okay, now I see. Yeah, because you can repeat the same thing. So basically the problem would be when you cannot do the full circle. You can travel around the circle once, because otherwise you can travel as many times as you want. Okay, next example 2. Gas 234 cost. You can start at station 0 or 1 as there is not enough gas. 0 or 1 to the next station. Yeah, if you start at 0, you need 3. At 1, you need 4. Let's start at station 2. So you fill up with 4. Tank is 4. Travel to station 0, which the cost is 3, so plus 2. Now you have to tank is 3. You travel to station 1. So from 4 to 0 is the cost is 3. Station 1, the cost is from 0 to 1. The cost is 3 again. 3 minus 3. So you have 3. So you're at station 1 with 3, but you need 4. You cannot travel back to station 2. It requires 4 units of gas, but you only have 3. Therefore, you cannot travel around the circuit once, no matter where you start. Okay, so n is so they have the same length, and it's n, and it's up to 10 to 5. The value is up to 10 to 4. Okay. So my mind is a little rusty. I don't know. But so this problem feels like it would be good to have some whiteboard to draw to solve it. Okay, so several approaches. Of course, we need brute force, if I could spell it. We could do some simulation. Including some super and that would be, by the way, that could include So ideas would be to somehow use dynamic programming. But okay, let's start brute force. If we just do simulate, like do the circles, it's pretty intuitive. That was because we're dealing with 10 to the power of 5. So if we go through the list, and for each node, we, through the circle, they call it circuit here. And for each node, we go through the entire thing. That will be n square, which can go to 10 to the power 10 to 10. That's too long. Now, so just the simulation just with the brute force is too long. Jesus, 10 minutes already? Reading that problem took some time. Okay, now simulation is kind of the brute force approach here. Maybe there is some more optimized simulation. Like such as so brute force is too long. But what if we what if, I mean, this circular thing is confusing, a little bit confusing. I mean, if we just start from any point, let's say from the end of this array, and we can have, I mean, we can know where the deficit happens. I mean, you can have deficit at some further spots, but as long as you have profit of gas in other spots, you can still make a circle. You just don't want to run. You don't want to start with the deficit. I mean, because if there is, let's say there is just two areas or two sections. What do they call them? Yeah, 2 stations or 3 stations, or like two distances we need to make to segments of the path, and one of them is positive on the cost, and the other one is negative. So you can the question is, are they net positive? If they are net positive, if overall, then you can make the circle as long as you start from the positive. From the positive segment. Yeah, that's kind of the math. Yeah, so you have some extra gas to deal with those net negative segments. And we can, obviously there could be many of those. Some may be positive, some may be negative. One of the cases could be they're all just zero sum, or zero, they're all even. Even like you get enough gas for each segment on each gas station. Well, that would be easy. And by the way, that means you can get from any, but that's not, but that it's unique. It's unique. You can't have, that's not going to be the case in this problem. But mainly you need to start with a positive, somewhere one of the positive, one of these. So we can return -1 if I feel like, okay, intuitively, that if it's overall it's net negative, then the total overall, that means you can't make the full circle, and that we can easily count, like in a linear operation. If it has enough, or if the total sum of all the stations have enough gas, if you just abstract from this multiple gas stations, and imagine there is only like 2 gas stations. If they two have enough gas to travel from one to another, then it's possible. But we have many more, so we have as many as we have. There could be many segments. So subsegments might have a problem with that. But you still need to have you need to have the total sum needs to be there. So that's kind of it's not the worst idea. So if you just check that sum, the total sum, it's already good to know that there is enough gas to do the circle in as a total. if that's the case, then yeah, total gas equal or more than total cost. Okay, if that's the case, then we can continue. Okay, so then we can see, is there still can be a risk of what? No. If the total is positive, then there should be some stations, some segments where you could get enough positive extra gas so you can handle those following. Yeah, let's take like a simple solution. There is one station that's like super positive, and like thousands of others that are negative. I mean, you can start with that positive and get through. Is that the worst case? Yeah, like 1,000 negative, like 99 negative, and 1 positive. And you just start with that 1 positive, and you'll have enough to go through the negatives. And yeah, so even though there are then yeah, you overall you will leave them less or equal than that you make. You will spend this, not more than you will get. Not more than you will get. So okay, let's assume that works. Then we need to see, okay, how we find that one. That and there is one solution, because there might be also 99 positives and 1 negative, super heavy and super far. Super far. One negative super far. So super far, 99% positives. I mean, if you have so many positives, whatever they are, positive trade. Gas positive segments. Then well, there could be a situation where you need all this positive extra gas to go through that one super costly negative. So there'll still be only one solution there. Could be that case. So how would you find it? Well, you do want to know the total negative. Yeah, if we knew the total negative. We knew the total sum of negative, the total, no, not just that, but yeah, the sum of negative, that will, just those, that will tell us how much we need. This problem reminds me of it looks like there is a prefix sum solution to this. Yes, prefix sum could be a solution because it kind of tells you how much, those total things. If we have prefix sum of both arrays, or maybe the net, what we want is at each point we want to have positive gas, not non-negative gas. We can't go below 0. And and by the way, the gas could be 0 also. The cost also could be 0. Yeah, so it feels like this problem is around. This is about using the prefix sum in a way. And it feels like the solution could be pretty short intuitively. And I really want to try the dynamic programming as well. So if you could, but since we have a circle, that means, does it really stop us from using dynamic programming here? The start at the end, the start, which is the end, also changes. So, I feel like it's a prefix sum. Okay, we're 30 minutes in, and I think it's a good I think we are on something here. Let me take a little break and maybe come back to it a bit later. Yeah. So thank you for watching, and we'll see you in the next video.